On June 26, 2020, at 12 a.m. GMT, a CoSpace Rescue Challenge map was issued to iCooL participants from around the world. All participants were given 24 hours to develop AI strategies to solve the same challenge. In CoSpace Rescue Challenge, teams are required to build a real robot, develop and program appropriate algorithms and strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. Additionally, they have to search and collect objects while competing with another team's robot that is also searching and collecting objects in the same real and virtual worlds. During the challenge, the robot needs to overcome barriers, avoid traps, and swamps. If the robot successfully makes a deposit, the points of the objects deposited will be doubled. The virtual field has been divided into a 3x3 matrix. When the robot moves into each section, the robot's corresponding location information will be assigned to the robot. Location information can be used for the development of AI algorithms and strategies, such as path planning and search algorithms. The winner of the challenge will be the robot with the highest points.
Hi everyone, I am Manhin from Raffles Institution, Singapore, and I am taking part in the CoSpace Rescue U19 FirstSteps category. I started robotics last year in the RoboCup Junior Soccer Lightweight category as our team's programmer. After winning our national championship, we represented Singapore and emerged as Super Team World Champions at RoboCup 2019. The iCooL Challenge is my first time trying out a different category of RoboCup, and it has been an interesting experience. The coding and testing process was a very lengthy and tedious one, involving a lot of experimentation as well as trial and error. I first spent some time working with the GUI and observing the code it generated to find out how my C code should look like. After gaining a better understanding of the robot platform, I then started implementing my strategies for my bot in C. Here's a rundown of my strategy. My first strategy was to collect two special combinations of the one red, cyan, and black for the bonus 180 points each deposit. Assuming the cyan objects are collected from the special zone, this meant in total I could get 420 points for each full deposit on average. Because of the way the playing field was designed, I reduced my bot's search space to a fraction of the field, more specifically the top left area. In this area, objects of all colors are available together with a deposit and no traps. The red objects were in the middle left cell, cyan in the middle, black in the top left, and the deposit was in the top middle. I decided to finish searching all these cells first before I would move on to the rest of the cells, where moving slower is necessary to avoid traps. Whenever my bot collected two objects of a certain color, I would remove that square from the search space so my bot could focus on the other two colors for the full bonus. After the bot was fully loaded, it will head for the deposit. In each square, my robot will bounce around to search for objects or the deposit, whichever it's looking for. I use reflection off the cell borders to keep my robot in the search space it is currently working on, and use a wall avoidance method to prevent it from colliding with walls and getting stuck. This wall avoidance involves using the bot's distance to wall, then to calculate a rotation rate so it will turn away from the wall, although this doesn't work at times. For movement between squares, my bot heads towards the target cell, but it also avoids wall by combining compass correction to point it towards the target and the previously mentioned wall avoidance. After implementing all these strategies, in the end, I was able to average 2 full deposits, which took about 2 minutes each, with a few more pickups at the end, giving me a high score of 990. After further testing, I found I was actually able to break the 1K barrier if I got lucky enough. This CoSpace journey has allowed me to experiment and implement various search algorithms. Through optimization and many strategy changes, I managed to improve my bot's performance and score. In the future, I would like to participate in more CoSpace challenges if the opportunity arises. Thanks for watching this video.
Hi, my name is Arav, I'm 14 years old and I'm from Bangalore, India. I'm excited to participate in the CoSpace FirstSteps Rescue Under 19 competition. When I was 7 years old, I got introduced to the Lego Mindstorm EV3 robotics kit. So since the past 7 years, I participated for more than 15 robotics competitions, including RoboCup, WRO, FLL and RoboFest. And during these 15 competitions, I have won more than 12 awards. And last year we got selected for the RoboCup Asia Pacific held in Moscow, and my team and I got the Best Technical Interview Award in Moscow. This year we got selected for the Japan RoboCup competition, but we were very sad to know that it was cancelled due to the coronavirus. But we were very happy to get to know when we got to know about the CoSpace virtual competition.
To improve the robot run, I have used the following strategies. Number 1. Search algorithm. In this, there is obstacle detection and trap zone detection. Number 2. Navigation algorithm to reach the segment which contains the orange zone. Number 3. Deposit algorithm. Number 4. Optimization of strategy algorithm. I will be explaining these strategies using a flowchart. This is my flowchart for the robot search algorithm with obstacle detection and trap zone detection. So first, the robot moves forward, and if the left color sensor or the right color sensor senses black, and if the number of blocks picked is less than 6, then it is going to set the key action to find objects and LED to 1 so that the robot can pick up the block. Similarly for the cyan blocks and the red blocks. But if the number of blocks picked is equal to 6, then we have another program for that program. And this is for the obstacle detection. So if the front, right or the left ultrasonic sensor senses an obstacle, then the robot turns until it's not seeing an obstacle. And this is for the trap zone detection. If the right or the left color sensor senses the trap zone, then the robot turns away from the trap zone. And after all of this is complete, it goes towards the start and continues the loop again. My navigation and rescue algorithm is based on the segments of the 3x3 matrix of the map. I have used the position of the robot to plan on navigating to the segment which has the deposit zone. Also, since the software does not allow us to use variables, I have used the set state as the placeholder to store values. Let me now explain the navigation algorithm using a flowchart. This is the navigation algorithm to reach the segment which contains the orange zone. If the loaded objects equals 6 and if the robot position is x0 and y0, then it will set state to 55. If the robot's position is x0, y1, then it will turn until it faces down, that is 180 degrees, and it will set state to 55. If the robot's position is x0, y2, then it will turn to the right, which is 270 degrees, and it will set state to 22. If the robot's position is x1, y2, then it will set state to 22. If the robot's position is x2, y1, then it will turn to 0 degrees, that means it will face up and it will set state to 22. If its position is x2, y2, then it will set state to 22. If the robot's position is x1, y1, then it will turn to compass 180 degrees, that means it will face down and it will set state to 10. If its position is x1, y0, then it will set state to 10. If its position is x2, y0, then also it would set state to 10. In the navigation algorithm, I explained about the 3 set states, which are 55, 22 and 10. These states allow me to plan on depositing the blocks at the nearest orange zone. Once it reaches the segment of the deposit zone, the robot will continue to move in that segment until it deposits. Now let me show you the flowchart of the deposit algorithm. If the set state is 55, the robot will set the state to 51. And if it is in the position x0, y1 or x1, y1, then it will turn right or left until it reaches x0, y0. If the state is 22, it will set state to 21. And if the robot's position is 02 or 21 or 01 or 22 or 21, then it will turn right or left until the x position equals 1 and y position equals 2. If the set state is 10, it will set the state to 11. And if the robot's position is x1, y0 or x1 y1 or x0 y1, then it will turn right or left until the x position equals 1 and y position equals 0. After I made the program, I tested the program in many different maps and I found out that I faced a lot of problems. So I made the optimization strategies. So the first one is, while testing I found out that the optimum speed is 60 because the robot senses the blocks and avoids the trap zone. Number 2, in the first 4.5 minutes, the robot will deposit only if the loaded objects equal 6. And this increases the depositing of the RGB set. In the last 30 seconds, the robot deposits the loaded objects in the orange zone even if the loaded objects is not equal to 6. And while depositing, if one sensor senses orange, the other wheel will turn until both the sensors orange so that it will find the orange zone. And this helps in the finding of the orange zone faster. Next, obstacle detection. We found out that the robot gets stuck in the corners of the map. To solve this, a condition has been given to check if all ultrasonic sensors are sensing an obstacle. If it senses, then the robot will turn until it's not facing the corner. And after depositing the orange in the orange area, the robot is set to move front. This makes sure that the robot went to all the places of the map. So this is the program that I have made. In the first, there is the deposit, which means in the last 30 seconds it's going to deposit. And these are the two conditions for the trap right and the trap left. And these are the deposits for all the 3 orange zones. And if the right sensor senses, it's going to turn until the left sensor also senses. This is going to make the deposition faster. And next, there is state 21, which means it's going to drop the orange in the x1 and y2. And this is all the neighboring segments of x1, y2. And it's going to move front. This is state 51, which means the orange is at x0, y0. And these are all the neighboring segments of x0, y0. This is for state 11. That means the orange is at x1 and y0. And these are the neighboring for it. Next, if the loaded objects equals 6 and if the robot ends at 0, 1, then it's going to move back. Similarly for all the 9 quadrants. And while it's moving front, when if it detects an red, it will pick for the right sensor and the left sensor. Similarly for the black and cyan. And the ultrasonic sensor, if all the 3 ultrasonic sensors senses an obstacle, it's going to turn, which means it has sensed a corner. And this is for the left, and when the left sensor senses, it's going to turn. Similarly for the right ultrasonic sensor and the front ultrasonic sensor. And this is the forward statement where it's just going to move forward in the speed of 60. I had an amazing experience participating in the CoSpace competition. This is the first time I am participating in this competition. I enjoyed thinking of different algorithms and coding them. While testing the algorithms, I came across many issues. Through this, realized that testing the code is extremely important. My logical reasoning skills developed and I could think out of the box. For the first time, I learned to create flowcharts to explain the algorithm. Thanks for giving me this opportunity.
And off we go! In this demo game, we will minimize any manual intervention. Red robot has a set of red, black, and cyan objects. Blue robot is searching in the blue spatial area. Any objects picked up in this area will double in value. Blue robot has two sets of red, black, and cyan objects. Red robot is depositing. Blue robot is depositing. Red robot is searching in the blue spatial area. Any objects picked up in this area will double in value. Red robot has a set of red, black, and cyan objects. Red robot is depositing. Blue robot is searching in the blue spatial area. Any objects picked up in this area will double in value. Blue robot is depositing. Red robot is full. Red robot needs to make a deposit before it can continue collecting. Red robot is depositing. One minute left. Blue robot is depositing. Red robot has a set of red, black, and cyan objects. Red robot is full. Red robot is depositing. Blue robot wins this challenge. Congratulations!